This video is on AMATS chapter 14.1 Integration. In short, integration is just the reverse of differentiation. Now we have learned in the past, quite long ago, that when we have y equals to x squared, our dy dx is simply 2x. But there are other cases when dy dx will also be 2x, although the y is different. For example, y equals to x squared plus 3. So we also have dy dx is equals to 2x. Maybe we have y equals to x squared minus pi over 8. We also have the same value for dy dx, which is 2x. What this actually means over here is that for all these different y graphs, so the first one we have y equals to x squared. For y equals to x squared plus 3, and the graph at the bottom minus pi over 8, so we expect a graph at the bottom y equals to x squared minus pi over 8. These are three different graphs, but for the same value of x, for example, when I choose an x value of 2, the same x value for 2 will result in the same gradient for all of them. Now this is not drawn to scale, but the idea is that at all of them, when x goes to 2, dy over dx for all of them will result in 2 times of 2, which is 4. So this is the same for every single point that we can choose for 3 graphs. So when we say that integration is the reverse of differentiation, we are saying that we start off with given dy over dx is equals to 2x. Find an expression for y. So we work backwards. And quite clearly, we see that based on dy dx equals to 2x, y has many options. It will be x squared plus 0, or x squared plus 3, or x squared minus pi over 8, etc. And the list goes on forever. We have an infinitely great number of possible expressions for y. In other words, when we integrate 2x with respect to x, we will get y. Okay, this is the reverse of differentiation. Y is the integration of 2x with respect to x, and this will result in x squared plus a constant. Now these constants can take on many different forms, so we just call it simply c. Now let us do a quick check. If we were to differentiate, okay, so if we start off with our ending, given y equals to x squared plus c dy over dx. Now we know this is we are very familiar with this. This will give us 2x, and when we differentiate a constant, we get 0. So based on this, we know that, hey, we did our integration correctly. C over here is known as an arbitrary constant, which we must always remember to include when we integrate. Now in some questions, you are given extra information. For example, they will tell you that dy over dx is equals to 2x, and they also tell you that there is a point 1, -2 lies on the curve. So find y. Okay, let us write straight away that y is the integration of 2x with respect to x. So the reverse of our differentiation, integration is our reverse of differentiation. in the past, for differentiation, we always bring down the power. Okay, bring down the power and the power reduced by 1. This time for integration, we are going to reverse it. You see the constant 2 over here? Just like our differentiation, we're going to just bring it to the side first, and we're going to integrate x with respect to x. Compare this with d over dx of our 2x with respect to x. Okay, when we have a constant over here, we can simply bring out the 2 and we differentiate x with respect to x. So this gives us 2. Okay, same thing, we're going to bring this constant out and we're going to integrate x directly by itself. And the formula goes like this. When you are differentiating, when you are integrating x to the power of n, in this case n is 1, we are going to write down x to the power of the original power. We're going to add 1 to it, because in differentiation we always reduce the power by 1. Now in integration it is the reverse, so we'll increase the power by 1, and now we will divide by the new power. Okay, so now we can see that this will result in 2 divided by 2, so they cancel off, and we have an x squared term, which x squared, if you differentiate, we know straight away we will get 2x. Now this is not the end yet, we still need to add our arbitrary constant c. So this results in x to the power of 2 plus c. This is our y expression now. But they also tell us that, hey, when x is equal to 1, y is equal to negative 2. So let's do the substitution. 1 squared plus c. So in this case, c is going to result in negative 3. In other words, y is going to be x squared minus 3. This is the equation of the original graph, which when we differentiate, we get 2x. And we also have a point 1 comma negative 2 lying on the curve. Okay, so if you look at your textbook page 431, you see the formula given to you. When you integrate x to the power of n with respect to x, your answer will be x to the power of n, the original power. We're going to add 1 to it. We're going to divide all this by n plus 1. And don't forget your arbitrary constant c. Okay, so just to do a quick check, we're going to try and differentiate our right hand side. We see whether we get our x to the power of n. Okay, so let's differentiate with respect to x. On the right hand side we have x to the power of n plus 1 over n plus 1 plus c. So differentiating this on the left hand side, it is the same as 1 over n plus 1. This is just a constant, and we differentiate x to the power of n plus 1 plus differentiate our constant c. I know many of you will be able to skip this step, but just to write down every single step clearly. So now we have our constant 1 over n plus 1. Differentiating x to the power n plus 1 will result in bringing down the power n plus 1, and our x will have a new power of n plus 1, and we reduce the power by 1. And on the other side, differentiating a constant is just c, which is c will result in 0. So here we get to cancel, and our result will be x to the power of n, which is exactly what we were trying to integrate in the first place. Okay, so the worked example, where we want to find integration. This is work example number 1. We want to integrate x squared dx. Simply copy down x squared, you add 1 to the power, divide it by the new power plus c, and this will result in x power 3 over 3 plus c. Then in part B, we are given that dy dx is equal to 1. Now in this case, they tell us that when they differentiate y, with respect to x, it results in 1. So when you integrate 1 with respect to x, we are going to end up with y. Okay, so now our formula states that when I integrate x to the power of n, but in this case there's no x, we can force an x to appear by giving it power 0. So this is equal to 1. And we use our same formula. This is going to result in x to the power of power 0 plus 1, which is 1, divided by new power of 1 plus c. And this is x power 1, which we don't even need to write it. So y equals to x plus c. Okay, now you try and practice now 1. Pause the video and do practice now 1 and check your answer. The next part, chapter 14.2. The header is 2 rules of integration, but it's actually whatever we've already covered the basics. Much earlier when we were doing differentiation. Remember when we were differentiating a constant multiplied by x, for example, plus 2 power 5? What do we do with this constant k? We could simply put it at the side and we focus on differentiating our x plus 2 power 5. Okay, so if you were to continue, this will require us to use our some of our rules. So bring down the power, x plus 2 power 4 and multiply by 1. So this k over here could have been just simply brought outside. In fact, it is the same thing for our integration. When you're integrating, for example, k times of a function with respect to x, we just bring the k out of the integration sign, fx and dx, and you just continue with your integration. Now this k over here must be a constant. It cannot have an x inside. So let us take a look at work example number 2. Let's try part B. So we're given that dy dx is equals to k. Again, there is no x term, but we know that, hey, this is actually x power 0. Okay, so when I integrate both sides with respect to x, my result will be y on the left hand side equals to, bring out your scalar multiple, x power 0 with respect to x. So k remains as it is, x to the power of 1 divided by 1, which we actually don't even need to write in future, and this results in kx plus c. So you may pause the video now and try practice now 2. The second rule of integration is again very similar to one of the rules that we learned for differentiation. When you differentiate fx plus or minus gx, the result is simply differentiate with respect to x our fx, and depending on whether it is a plus or minus sign, you differentiate your gx. So as long as you're familiar with your differentiation, you should not have any issues with your integration. So let's go straight to practice now number 3. I'll be doing 1a. When we integrate 3x multiplied by x minus 7 dx, given that right now we are still differentiation is still very fresh in our minds, hey, this looks like a product rule. Is there a reverse of product rule for integration? Maybe there is, but we don't need to worry about that, because over here we can expand it and we will arrive at 3x squared minus 21x. All of this will be integrated with respect to x. So now we can do each of the terms, we can integrate each of the terms by itself. Okay, so without going through all the hassle of bringing the power out and then writing integrating x squared blah blah blah, let's do it all at one go. So we copy down the coefficient, write down the x, increase the power by 1, so 2 plus 1 will be 3, divide this by the new power, how convenient, they will cancel off. Copy down the minus sign, copy down the 21, x currently power 1, increase the power by 1, we get 2, and divide this by 2. So add your brackets when necessary, and we add a constant c. We do not know the value of this constant c. So cancelling them off results in x cubed minus 21 over 2x squared plus c. Okay, so practice now 3, question 1b, c, and question 2. Take note that question 2, they tell you that curve passes 1, 1, which means that after you do your integration, so over here we have y equals to integrate the integration of 2 minus 3x plus 4x squared, all this with respect to x. When you finish this, you will get, all the powers will increase, right? You'll have something x plus or minus something x squared. So I'm increasing all the powers, plus or minus something x to the power 3. Then you have an arbitrary constant at the end. So once you have all this, you sub 1, 1. It is a point found in this curve. Back here to find c. And your final answer will be y equals to whatever you have of x plus whatever you have of x squared, x cubed, and plus your value of c inside here. And that is the end. Okay, so our homework for today, our homework that is also due on Thursday from exercise 14a. These are the questions from exercise 14a, due on Thursday.